Welcome to homework.
The following reaction, the first step is to be sure to balance it before looking at calculating the percent yield. When this equation is balanced, the coefficients are 1, 4, 4, and then the products are 1, 2, and 20. It's also helpful before we start to find the molar mass of the compounds involved in the reaction. We find this by adding up the individual molar masses, including the hydrates or the waters, using the periodic table. So for the first compound, the molar mass is 322.24 grams per mole. My second reactant has a molar mass of 126.07 grams per mole. And finally, the product that we form here has a molar mass of 541.66 grams per mole. And so the question tells us that we start off with an initial amount of both reactants. We have 1.68 grams of the zirconium reactant, and we have 5.20 grams of the oxalate reactant. And we know that we produce 1.25 grams of the product. To find the percent yield, we need to figure out what the theoretical yield is, or how much is actually produced. So we need to solve for the theoretical yield, or the calculated amount. So to do that, we have both reactants in grams, and we change to moles using the molar mass. And then we have moles of the compound, we change to moles of the product. And we do that by using the balanced equations, the mole ratio from the balanced equation. And then finally, we can change to grams of product using the molar mass of the product. Because we're given both reactants, we need to do the steps for each one. And look for which reactant produces the smaller amount. This will be our theoretical yield. So the smaller amount produced is our theoretical yield. So let's start with the zirconium complex. .68 grams, which we change to moles by dividing by the molar mass. And then in looking at the balanced equation, see that it's a 1-to-1 ratio between the product and the zirconium. For 1 mole of product, for every 1 mole of ZrOCl2.8H2O. And then we change from grams to moles of product, multiplying by the molar mass, or 541.66 grams for every mole of product. Or we produce 2.83 grams. Similarly, looking at the second reactant, H2C2O4.2H2O, which we start out with 5.20 grams. We change it to moles using the molar mass. (126.07 grams). And then in this case, when we look at the equation, there are 4 moles of reactant for every 1 mole of product. And then we multiply by 5, 41.66 grams per mole, where we would produce 5.59 grams. This number is the smaller, so that's the theoretical yield. So our percent yield is how much we actually produced, which is 1.25 grams, divided by what we should have produced, 2.83 grams, times 100, or 44%.